three criteria, that is rule of thumb. The small value is 0.25, middle 0.5, medium. And the large, that is 1. Dr. Kijaz knows lesson 9. This is 0.2 for small, 0.5, and 0.8 for large. I think you can use both one. So in this example, the mean difference x minus mu, standard deviation of sample 15.1. So x bar how much is this one?
Zero point 165.
165. Okay, we can see the effect size small. So this situation, the effect size is small. What does this effect size mean? So this situation, the degree to which a phenomenon exists, the degree is very small, only 0.165.
I don't know what you mean by the degree to which a phenomenon exists. I don't know.
It means this situation will happen in a real situation. Maybe. If you use probability a lot,
I mean, how is that different from saying the standard score? How is that different? I mean, you say, well, it's 2 standard deviations away from the mean, and that's, to me, is the degree to which a phenomenon exists. But how is that different from this, where you're saying the degree to which a phenomenon exists? You know what I'm saying?
I know, because I don't know how to explain more clearly now.
Yeah.
Do you remember the independent variable and the dependent variable? In the other chapter, you will learn another kind of effect size. We usually use large effect size to check the independent and the dependent variable relationship.
Is it kind of like a correlation?
Yes, you can say that is like correlation, but that is not correlation coefficient. But we can judge is the effect size is big. Okay, your influence is more powerful because test only tell you it is significant or not significant.
But this tells you how significant.
Yeah, how much? How is the power? So in this situation, there is no independent and dependent variable.
I have another definition here. It says the effect size is a measure of how different two groups are from one another. It's a measure of the magnitude of the treatment, kind of like how big is big. And
That is I say, independent and dependent. And you compare two, and you see, oh, how much powerful.
Okay.
But this situation, yeah, the degree which the phenomenon exists.
All right. So you would expect if we have a significant if we pass the point of critical value and we're saying that there is a difference between the two means, then probably the effect size is going to be large.
You say that again? We compare two means,
Right.
and
And we would probably say if that we will have a large effect size if we reject the null hypothesis.
no, we can't.
We can't say that.
You only can say this situation happened in a real phenomenon.
Okay.
The probability is higher. The effect size is big. The degree is big. Okay. Anyway, the assignment assignment 5, question 1, 2, 3. Well, you must compute effect size and use the formula and to judge small, medium, or large. That's it. Oh, take a break. Only compute one question.
Since the break time, I've turned in assignments for 5 already, but I didn't know number 2 very well. And I tried to use the T.
I did it today.
Oh,
Well, I did a little bit last week,
That's
here and there, but I didn't understand it because we hadn't learned the rest of it. We hadn't learned the effect size, or all the other things.
But I can't imagine how. You were not there back then.
Since we're so much, that you have to handwrite some answers.
Is that what they touched you?
He's given us pages, numbers to memorize certain things earlier today.
Couldn't make
Page 1,000.
she fell. She's a member of 34 steps or triggered it. And I just quickly ran the She's 77.
The other side is the
I ran home and ate
kind
some
of
food.
question.
They're coming to bed, like, you gotta do what you gotta do.
That's why yesterday I was going to study my son visiting from LA with my grandbaby, everything, you know, all these things. But I have visiting. My kids are
What did you choose? Yeah, that's
very.
Do you have?
They're the ones I looked through and I'm like, I don't know these very well. And I
Now,
don't
one of
know
them
this.
is so my house.
You just, I know. Just
Oh my gosh, I get up in the morning yesterday, and I love it. I mean, sure, I'm on my bed, I'm just hiding in my room, gonna get devotions, right? That's when I go to work, so I'm sitting there, down in one second. And one of my chickens knock on the door, come in, so my one daughter will watch, she's like, pops herself on the bed. So I go, okay, Lord, this is good. And then 5 minutes later, another one, so Grace pops herself in the bed.
Tell me a
So
little
and
about
then
it.
Okay, I think we don't have enough time. I hope to finish in 30 minutes.
I have the pages folded, and I'll let you
Now,
know the page.
we know the TOEFL test. The mean of TOEFL is 500. The standard deviation of the TOEFL test is 100. TOEFL?
Test of English is a foreign language.
Yeah. Test of English is for foreign language. Yeah, that's for me. For the international student. The mean is 500 and the standard deviation is 100. So now you have the mean of the population 500. Standard deviation of the population 100. One group 25 people. Get test the score mean, that is 48 for the group mean. This sample mean for 480. Standard deviation is 95. Okay, now you can compute the standard error, that is sigma over root n. Sigma is 100 divided by the root of 25, that is 5. So the standard error is 20. Is this group mean less than? Less than, so set up your hypothesis. H0 always equal.
Can you slow down just a little bit?
Okay.
Sorry.
So the first you can get the number from the question. This number we need this number. The first step, set up the hypothesis. No hypothesis, alternative hypothesis. No hypothesis always equal. Alternative less than. The central mean less than, smaller than mean. So this is the rational. Two tail or one tail?
One there.
One tail. So you must memorize. Directional, one tail. Non-directional, two tail. If this direction, one tail. Okay. So alpha degree equals 0.05. In social science, it's very important. When you finish your quiz, you will know why this is important. So critical value, because we know the sigma, standard deviation of the population, so we use z-score. And the z-score, z normal distribution, one tail. Okay, one tail. Because less than, so left side. Left side. And you check, this is 0.5, 0.05. When you check your table, you will get 1.6449 negative yield. You also can use negative 1.645. So critical value for this question, negative 1.645. Okay, so now the third step, you will test statistic, mean minus mean over standard error. That is mean minus mean. Standard error 20. I don't like this one. Sorry, we change this number to 460. The group mean only 460. They are not study hard. They don't study. Okay, then you will get negative 2. Where is negative 2? The critical value is negative 1.6. So negative 2 fall into rejection area, the region of rejection. So you can reject. The last step, because test the value, test the statistics. That is negative 2. Exceed critical value. Negative 1.645. Therefore, we can reject non-hypothesis. So the result, the group mean is less than total mean, the population all the world. elevation.
You said, was writing the test, you said that the test statistic falls into the region of rejection, right?
Yep.
And you said it exceeds the critical value.
Yeah, because -2 exceeds -1.625. You check the magnitude, the 2
So you're
bigger
talking
than
about the absolute value of it, that really. Because -2 is not more than negative.
not the magnitude.
Okay.
The magnitude is exceed. So when you check this figure, it fall into rejection area. Or you can write the test statistic fall into rejection area. This is the same meaning. When the test statistic exceeds critical value, your test statistic will fall into rejection area. Therefore, reject non-hypothesis. So this group, they have the less mean than total population. Okay, now here is the testing. We do the estimate confidence interval. So confidence interval 95%. Pay attention, it's always like two tail because in the middle that is 25%. So the critical value is positive and negative 1.96.
Sorry, even though we're doing a one-tailed test here?
Yes.
Okay.
So CI between the area negative Z, negative 1.96. Standard errors 2. 20 plus the mean. Hello? 460. Sorry. I cannot get
420.
The minus?
how much?
420.8.
428.
420.8.
428. Okay, so for this situation, the researcher will have 95% the chance the mu fall into this range. from 420 to 499. Okay, effect size. Mean difference. Mean difference over standard deviation. Mean difference over standard deviation of group. How much? Oh, 95. Ooh. This example is this right? Negative point. Which one? This question.
Confidence interval question. One side of the equation is negative 1.96.
Yeah, 1.96.
The other side looks like 1.76.
1.96.
And then, oh, and then you changed the 480 to 460.
Yeah, this
Got
is
it.
460. Sorry.
No problem.
Do you remember the criterion?
Almost.
Good. So it's close to median. So effect size is median. Your answer. Effect size is median.
So on our homework assignment, when you're asking for the effect size, you're not really asking for the figure. He wants to know small, medium, large.
He only wants you to know the procedure, how to compute and judge small, medium, or large.
Did you find out the actual critical value of the DF of 35?
I must check the T table online.
Okay.
I know some T table will give you one BF from 2 to 100 every BF. So this is one way. Another way I recommend use the average of 30 and 40. Use the average.
Oh, what's in between the two, just add them together?
Yeah,
and
add
divide
it divided by 2, and you can compute confidence interval.
All right.
I think if you use 30 or 40, that's right.
It doesn't matter because I already have.
Because Dr. Pijano, you know how to
The procedure.
compute. Yeah.
I'll just leave it.
Now we discuss the t-test. Wow. Do you follow me? Okay, so I erase. I need the question. Where is t-test question? Okay, page 193. Example using the t-distribution. Okay, in the middle, the graph, you can read now. Suppose the pardon? 193. 193. Example using the t-distribution. Suppose the athletic director is large. Data supply biography, researcher review, GPA for the university is 2.5. Okay. GPA for university 2.5. Select 20 students. Their GPA 2.45. Sample standard deviation is 0.45. 0.54, sorry. Okay, now write down the number you have. The mu 2.5. The sigma, we don't know. The mean of sample 2.45. The standard deviation 0.54. N, how much? How many? 20. Okay. In this situation, we use the t-test because sigma unknown. Sigma is unknown. We use t-test. Let me introduce the t-test. T-test because when the gasset, I think in the textbook, gasset, he found when the sample, the number of sample is small, the normal distribution, the distribution is not normal. Sometimes high peak, sometimes they are late. Okay, in your book, it's different with my learning before, because the book said late. I learned before that is high peak. If this is normal distribution, your N normal distribution N equal to infinite, many cases. But N equal to 15 or 30. 30? 15. It will become late if equal to 5 more late. Because it changed, the distribution changed. So your rejection area changed too. When so if your case number is 15, you want to set up two-tailed test and to find the critical value for your rejection area. The value will be changed. Different with the Z distribution. And the different N has different distribution. So when you check the T value, the critical value, you must memorize what is your N, what is your sample, the case number of your sample, because that influence the critical value of T distribution. Okay, this question. First step, set up the hypothesis. Please memorize 4 steps. That is important. Do you know what I mean?
Yes.
Okay, you know. So set up H0, H alternative. What is H0 analysis? They are equal, always equal. Alternative, so you must check different or greater or less than. To this question.
Says less.
Less. Which line?
Right underneath step 1.
Example using the T distribution in the last paragraph. I am looking for the word different or less than or greater than.
Oh, in the second line it says you're not doing as well.
Your GPA is less than.
Okay, second line. You are right. Athletes are not doing as well. My English is not good. I think this means different. As
Not as well means they're not as high.
Okay.
It's less.
Less than. Not as well. Less than. So the sign is smaller. Smaller than me. Okay. So you know this is directional. Pay attention, directional, because you have directional. Directional, one tail or two tail.
One more time. Why is it one tail?
Directional, we use one tail.
direction.
One tail. What is the two tail?
Non-directional. They are not equal. Okay, set up hypothesis 0.05. So the critical value. Check T table.
644.
Okay. You must check table C3. C3 is okay because the distribution of T score, they will change according to the degree of freedom. The degree of freedom that corresponds to your number of tests. N-1. The easy way to memorize how many mean you minus the number. If one sample you got one mean, so you minus 1. Next chapter, 2 sample. They will compare 2 samples and you get 2 mean. So the DF will change, become N-2. So in this chapter, you only need N-1 because there is only one mean, degree of freedom. So you check the table, the left side. DF, this question, 20 students. So DF equal to 20 minus 1, you must check the 19. 19, okay. The row, pay attention. There is 2 rows. The ceiling. The first row is one tail that we need. Okay, one tail in the 0.05, so second column. Second column. 1.729. So critical value That is T. 1.729. Any question? Only this step is different with t-test. You must know how to check t-table. So if the question is non-directional, two-tail, you must check the third column. Pay attention, because third column is the label for the two-tail, and the significance is 0.05. Okay. The next step. T-test, the formula is like Z-test. The mean minus mu, but over, now there is no standard error. We can use estimate standard error. This is estimate the standard error. Because we use the standard deviation of sample to estimate standard error. The formula is the standard deviation of sample over root n. So it's like standard error, right? So this question, S is 0.54 over root n 20. How much?
4.472
4.472.
is square root 20.
The whole thing is.
The whole thing is
The whole thing is 0.12.
0.12. Okay. 1 to 1.
1, 2, 1.
So we put the number into the formula. The mean 2.45 minus the mu 2.5 divided by estimated the standard error 0.121. How much? This must be negative.
Minus 0.42.
Minus 0.42. You check textbook. It's how much? Now, exceed or not exceed. This is T distribution, and the critical value here, 1. Okay, because left side and the symmetric, so critical value of T must be negative, because this is smaller situation. We test the left side. So this T value is negative 1.729. T distribution is symmetric too, like normal distribution, but its peak is not normal peak.
Is that mine? Because I don't know.
I think this is yours.
Thank you.
Am I right? Am I right? Page, where am I? Page 1.
The T,
No.
yeah, it's 194.
194. Okay. The book used negative 1.73 because it rounded. So the next step, because test statistic. That is negative 0.42. 0.42会脱 P， negative 0.42. So it didn't fall into rejection area. Because test statistic doesn't exceed critical value. That is next 1 point. Therefore, we can't reject. What's this? Doesn't exist, we can't reject. I think you don't need to. If you draw, it's better. Okay. Any question? No. It's important. The confidence interval. So this part is testing. Now we do estimate. So pay attention. Because we don't have the sigma, we don't have the standard error. Now we must use the estimate standard error. Okay, so the formula becomes the critical T negative at left side time estimate standard error of S and the small x bar minus the mean plus mean, sorry. This side T. So look like the z-test confidence interval. Any question? If the question asks you construct 95% CI, where is the critical value for T? You must check the table and pay attention to the two tail, because the middle part is the CI, so that is two tail. The DF the same as the question 19, and check two tail. So third column, table C3. Because third column is the two tail for the alpha degree 0.90 or 0.05. So 95% CI the same meaning. Alpha degree equal to 5%. So you check the table.
So when we do the T, even the minus T is the same as the other side, right?
So how much? Well, it's higher. 2.093. So this is negative 2.093. Time estimated standard error. How much? 0.121.
Ting,
Yes.
I lost how you got the 2.093. I'm looking at the table, but I'm not sure where.
The third column and the DF degree of freedom
Yes.
equal to 2.093.
It's
Because T-
19 number.
Oh, it's still 19, but it's the, okay. Great, okay, thank you.
Okay, you got it?
Yes.
So here is 2.9093. Symmetric here, negative 2.093. The mean, how much? 2.45. Okay. Can you give me the result? How much? Left side and right side. Oh, we don't have this part in textbook.
No, it is not
Yeah.
a textbook, I don't think so.
So nobody confused. Okay, I can complete. Okay. What is this answer mean? Confidence interval between 2.197 to 2.703. It means you will have 95% chance the mean population mean GPA score fall into from 2.19 to 2.703.
So every time we've done that, our mu has in fact fallen in there.
Can you say that again?
Every time we've done the confidence interval, our mu has in fact fallen in that range. But what happens if it doesn't? What if it's in the 5%
Because
that's,
we reject, right, then we made a false rejection.
Let me tell you, if this range included 0, the result is significant in testing. You can reject the null hypothesis. So this area doesn't include 0. So this you cannot reject the null hypothesis in the testing. Do you remember the last question I just did? The range I remember included 0. Confidence interval. This is another way to judge, but we use confidence interval to estimate the mean of population. That is the function. So this is the relation between confidence interval and the testing. I always say that is the reverse direction. You compute this way in the testing, but you do the backward way in the estimate. Effect size, it's easy. Mean difference 2.45 minus 2.5. SD 0.45. 54. How much? Wow. It's weird.
It's like negative 0.05 divided by 0.5.
Okay, negative point. This is about negative 0.1. So check the magnitude. Only 0.1. Yeah, very small. Mean.
So when we figured out, we calculated, when we're asked, write a report on the analysis, what does the report, can it be a sentence?
Yeah, that is
I
sentence.
mean, when I think of a report, I think of more than a sentence, so.
We
It's
have,
like 2 pages.
Yeah, that's what I'm thinking of, yeah.
we have,
Yeah.
for this example, we have 95% chance to get population mean fall into 1.2. So confidence interval is a range, and your mu, because now you estimate the mu, you don't know the mu, it will fall into this range,
So.
and the chance 95%.
So if I have like a little chart of that with the two tails, so for instance, you would put the minus, so to get a visual here,
So
right, the minus.
in the figure, this is t distribution,
Right,
and the t score here is how much? T score 2.093 and negative 2.093. In the middle, that must be 0 for t score. Then the row score, this is the x bar. Where is x bar? 2.45. And here, 2.703. Here, 2.197. Okay, so this is, if you draw the figure, this is the figure mean. So your mean, population mean will fall into this range from 2.197, that is GPA score, to 2.703. And this change is 95%. Minus 0.0. This is effect size, but we check the magnitude. Yeah, so you must memorize 0.25, 0.5, and 0.1. That is 1. So this is small, this medium, this large. 0.1, that is small. So effect size is small. Okay, any question? Okay, we will have another lab time, tutoring time, on Monday 1:30. I think the classroom will be in the seminary. I will send email to you. If you are free in that time 1:30, you can come, and I can explain. Okay, resolve your question. Thank you.
I think so.
we can go on to the next section if you want.
Yeah, it'd be nice. This is kind of confusing.
Okay.
The classes, they say they can hardly see.
Yeah. Turning my light. Turning it back. Okay. Sentence combined. On these pages are some sentences. Read the sentences, combine them into one sentence, and write the sentence in your booklet. Look at the practice item. Tom is big, Tom is a man. What is the best way to combine these two sentences? Write your answer on the line under the example in your booklet. The best way to combine these sentences would be to write, Tom is a big man. You could write, Tom is big and he is a man.
Tom is big because he is a man.
But this is not the best way to combine the two sentences into one sentence. Some of these items are easy and some are hard. Some items have two sentences, but others have three or more sentences that need to be combined. Remember, combine the sentences to make one and only one sentence. Work as quickly as you can. Begin with item number 1.